Hello, how are you, geometry students? I hope you're doing well. 6-2 is proving lines parallel. So we're going to learn about the relationship between angles in a figure like this. Let's start with some anatomy. So we have this pair of parallel lines, M and N, and the line T here that cuts through both of those parallel lines is called a transversal. So I've drawn this arrow to point to it, and once the transversal cuts through both parallel lines, it creates 8 angles, as you can see from this. And these 8 angles have a whole bunch of different relationships with each other. So let's look at some of them. There are corresponding angles. There are alternate interior angles. And there are supplementary interior angles on the same side of the transversal. I'm going to talk about what each of these are. There are other angle relationships too, but these are the ones that are have most to do with this particular lesson. So let's talk about this. Where are there corresponding angles? Well, one pair of corresponding angles is angle 1 and angle 5. They are in the same position relative to one of the parallel lines in the transversal. Angle 1 is above one of the parallel lines and to the left of the transversal. Angle 5 is above the other parallel line and to the left of the transversal. So they are corresponding angles. Another pair of corresponding angles, 2 and 6, above the parallel lines to the right of the transversal, and 3 and 7, below the parallel lines to the right of the transversal, and finally 4 and 8. Below the parallel lines to the left of the transversal. Alright, so these are 4 pairs of corresponding angles. And all these you're going to have to be able to recognize. You're going to have to know that off the top of your head. So you really should take the time this lesson to make sure you understand and you can recognize. Because quite frankly, if you can't recognize those angle relationships, you're going to struggle in this chapter. So we don't want you to do that. So make sure that you are making yourself aware of these angle relationships. 4 pairs of corresponding angles. And alternate interior angles. 4 and 6 are alternate interior angles. And then the other pair of alternate interior angles are 3 and 5. Why are they called alternate interior angles? Alternate because they are on opposite sides of the transversal. 4 is on the left-hand side, 6 is on the right-hand side of the transversal. Interior because they are inside the parallel lines. They're in the interior of the parallel lines. Right, and that's why they're called that. Supplementary interior angles on the same side of the transversal. Okay, so if you picked up on what we said about interior angles before, interior means inside the parallel lines. 3 and 6 are inside the parallel lines, and they're on the same side of the transversal. So those are interior angles on the same side of the transversal, and later on we're going to learn that they are supplementary. So that's one pair. 4 and 5 is the other one. So 4 and 5, both on the left side of the transversal, inside the parallel lines, the interior of those parallel lines. So they are supplementary interior angles on the same side of the transversal. What else is there to notice about this figure? Do you see all the pairs of vertical angles? 1 and 3 are vertical angles. 2 and 4 are vertical angles. 5 and 7 are vertical angles. 8 and 6 are vertical angles. So you know that they're equal to each other. 4 of the angles are obtuse. Those are the red ones, the odd-numbered angles. 4 of the angles are acute. Those are the even-numbered ones, the blue ones. Did you notice all the linear pairs? 1 and 2 are a linear pair. 2 and 3 are a linear pair. 3 and 4 are a linear pair. 5 and 6 are a linear pair. 6 and 7 are a linear pair. 7 and 8 are a linear pair. 8 and 5 are a linear pair. Lots of linear pairs. In fact, here's the interesting thing about this, the relationship between all these. did you know that if I know one of these angle measures, like let's say that I know that angle 1 is 140 degrees, with that piece of knowledge I can find all the angle measures in this. 2 is 40 because it's a linear pair. 3 is 140. You have all kinds of ways to show that it's 140. Vertical angle to angle 1, linear pair to angle 2. 4 would be 40 degrees. 5 would be 140. 6 would be 40. 7 would be 140. 8 would be 40. So there are only 2 angle measures in a figure like this. And unless you have a perpendicular line for a transversal, one of those angle measures is going to be an obtuse angle measure, and the other one is going to be an acute angle measure. So that's a lot of information packed into this one slide about this type of figure. Now, what's the meat of this particular lesson? You'll see on the next slide. Here's that figure again. And Theorem 17 is the main event of this particular lesson. Equal corresponding angles mean that lines are parallel. So what if I didn't know these lines are parallel, but let's say that I knew that angle 7 equaled angle 3. Alright, according to Theorem 17, that's all I need to know in order to say that, well, these are parallel lines. M is parallel to N. So if I'm not told that they're parallel, but I am told that a pair of corresponding angles are equal, then that means that I can say that they are parallel lines. This Theorem 17 has 3 corollaries associated with it, involving the other types of angles. Corollary 1, alternate interior angles, equal alternate interior angles mean that lines are parallel. So if they haven't told me that the lines are parallel, but I know that angle 4 equals angle 6, then I know I have parallel lines. M is parallel to N because those are alternate interior angles. Equal alternate interior angles. There's always one mistake in there. Alright, mean that lines are parallel. Okay, Theorem 17, Corollary 2. Supplementary interior angles on the same side of the transversal mean that lines are parallel. Alright, so let's say I did not know that the lines are parallel, but what if I knew that angle 4 and angle 5 were supplementary? Then that knowledge could, with that knowledge I could say, well, those lines are parallel. Alright, so these are 3 good ways to tell from the angles that the lines are parallel. And then there's one more corollary here. It says in a plane, 2 lines perpendicular to a third line are parallel. So let's say I have this figure, and let's say I know this about this figure. This transversal is perpendicular to both of the lines. If that is the case, then I know that these 2 lines are parallel to each other, according to Theorem 17, Corollary 3. Now, in lesson 6-4, you're going to learn the converses of all these. Which one do you use when? If I've given information about the angles but not the lines, I use these. Now you're going to find out in a couple lessons that sometimes I'll know that the lines are parallel, but I won't know anything about the angles, and then I can use the converse of each of these. But I'm getting ahead of the game a little bit here, but I just want to foreshadow for you a little bit about how this all fits together, because it does fit together very, very neatly. Alright. Well, I believe that that covers everything.